It's too bad we can't put this machinery to work doing something useful like building desalination plants.
The hull for this sub isn't just made out of simple steel. It must resist unbelievable pressure. The Virginia class needs to reach depths of up to 800 feet. Here it's difficult for an enemy to find them and will give the submarine maximum safety from attack or detection. But at these depths, there's immense pressure. The steel hull must withstand a massive 370 pounds of pressure per square inch. That's the equivalent of a dinner plate strong enough to hold up to the weight of an elephant. Getting the steel strong enough to endure such pressure is crucial. The manufacturing of this special metal is a military secret. Let's just say it's strong. Really strong. But now the problem is how to bend such heavy-duty steel. They use a machine that supplies up to 5,000 tons of pressure. That's over 30 times the pressure exerted by this car-crushing machine. The massive drum shapes and bends the huge plates of steel. Once bent into shape, the steel is mounted onto rim-like frames. It's then welded together into cylinders. This is a critical moment. In the past, this was done by teams of hand welders. But such are the stresses on a deep ocean submarine that even one bad weld can lead to disaster. There's only one answer: robots. These assembly robots can work round the clock and rarely make mistakes.
The weldments that go in out here are better than 99% first-time yield, which means the inspection process is less than 1% failure rate.
It's a costly business, but this is a structure that can't afford to fail at any price. To make sure the welds are perfect, they are inspected by X-ray. Any imperfections, such as an air bubble in the weld seam, could be just enough to weaken the hull. It could then give way to the crushing forces exerted deep below the surface. If the X-ray machine shows up any imperfection, it's meticulously repaired. Amazingly, once the seam is perfect, the welds can create a bond that is actually stronger than the original steel. A comforting fact when you're 800 feet below sea level.